The following video is on combinations, permutations, and how to properly use both of them. What is the difference between combinations and permutations? The difference is whether or not the order of the options matters. In a combination, the result order is irrelevant. However, in a permutation, the order does have importance. Combinations and permutations each have two separate equations, one for if the results are allowed to repeat, and one for if they are not. In the following equations, n represents the number of things possible, and r represents the number of things chosen. Let's say you have 5 children, A, B, C, D, and E, racing each other for first, second, and third place. Now, if you look at this scenario, you can see that order does matter because they are competing, after all, for first, second, and third place. Therefore, it is a permutation. Now, because child A cannot have all 3 places and no other child can have any more than 1 place, we're doing this without repetition, which means we're going to be utilizing the equation n factorial over n minus r factorial. Now, since n is the number of things possible and r is the number of things actually chosen, and we only choose 3 out of the 5 possible children, that means that n will be equaling 5 and r is equal to 3. So when you plug this in, it comes out to 5 factorial over 5 minus 3 factorial, which equals 120 over 2, which then comes out to 60 possible permutations. So let's continue. Let's say you're playing a game where you have to roll 3 dice, a green die, a blue die, and an orange die, in that order. Now, because in this scenario order does in fact matter, we are dealing with a permutation. And because each die has the numbers 1 through 6 written on it, repetition is allowed because you can roll a 1, a 1, and a 1. So, since the formula for number of permutations allowing for repetitions is n to the power of r, and we're picking 3 out of 6 numbers, the expression is 6 to the power of 3, which comes out to 216 permutations. Moving on, let's say you order an ice cream cone with 3 different types of ice cream. For the sake of the problem, let's say they are blue, green, and orange. I have no clue what those taste like. Now, because order doesn't matter in this case because you're still getting the same thing no matter what order they're in, it's a combination. Also, because ice cream doesn't run out after only 1 scoop, we're doing this with repetitions as well. Now, the formula for combinations with repetitions is n plus r minus 1 factorial over r factorial times n minus 1 factorial. After you plug in the numbers, you get 3 plus 3 minus 1 factorial over 3 factorial times 3 minus 1 factorial, which equals 120 over 12, which comes out to 10 different combinations for ice cream. To finish off, let's do one final problem. Let's say there are 5 children, A, B, C, D, and E, and of these 5 children, 3 of them are going to be taking a survey. Each child is equally likely to be chosen for the survey, and order does not matter because of the fact that they're all going to be doing the survey if they are chosen. Since order doesn't matter in this scenario, we're dealing with a combination. As with before, no child can hold more than 1 spot, and it's for this reason that we're going to be running this without repetition. Now, the formula for number of combinations without repetition is n factorial over r factorial times n minus r factorial. And since we're choosing 3 out of 5 kids, when you plug this in, it comes out as 5 factorial over 3 factorial times 5 minus 3 factorial, which is equal to 120 over 12, which comes out to 10 different possible combinations.